Hello, I am Jayarama Reddy, former professor of physics and Vice Chancellor, Sri Venkateswara University. I will be talking to you today on aerosols and climate. Aerosols are airborne solid or liquid particles. They were of small size, a few nanometers to several tens of micrometers. It's not a greenhouse gas, but they greatly influence the Earth climate system. 90% of the aerosols are desert dust and volcanic ash, and volatile organic compounds from vegetation and smoke from forest fires. 10% are human-made, anthropogenic. They come from a variety of sources. Look at the picture on the left side. You see the desert dust rising above. You see that on the right side, the vegetation on the mountain and the volatile organic compounds, VOCs, are generating from there, which we were able to see with our naked eye. Look at these pictures. Left side is the smoke coming from the forest fires, and the right one is the ash from the volcano eruptions. These are all called the aerosols particles. Their lifespan is very short in the atmosphere, and they also vary with the location. Therefore, it is difficult to measure their quantities and assess their total effect on the Earth's climate precisely. The season and local weather allow aerosols surge into the atmosphere anywhere on Earth. In the northern hemisphere, streams of mineral dust swirl over deserts and arid regions, that is hot regions. In the southern hemisphere, slash and burn agriculture in the Amazon forest area and Central Africa, mostly in the Congo and the neighboring countries, releases large amounts of smoke and soot. Forest burning during summers in Brazil, Canada, Russia, and the Western US release large amounts of aerosols. Smoke from wildfires in Siberia and Canada can reach the Arctic ice cap, that is North Pole area. The satellites detect these particles over both water and land. Strong winds of the roaring 40s latitudes, roaring 40 latitudes in the southern hemisphere, that is around between 45 to 50 degrees. They have gusty winds in those latitudes, and they are called roaring 40s by the sailors who traveled through that region in the earlier days. They create a heavy band of airborne salt north of Antarctica. Antarctica is the South Pole land area. Massive spirals of dust blow above deserts. Desert dust aerosols, they absorb and scatter solar radiation. They do both the things. They absorb some heat and they scatter some heat. Minerals in the dust aerosols absorb sunlight, warming the adjacent air. This warm air prevents forming of storm clouds, preventing rainfall and furthering desertification. Solar radiation scattered by the dust do not reach the earth, hence cooling takes place. Large grains of airborne sand fall to the ground, but the smaller particles, the smaller grains, can remain suspended in the air for about a week or more, and even can travel vast distances along with the wind. These grains, moving with the atmosphere at 5 meters per second, will travel thousands of kilometers in a week. Dust clouds from the Sahara Desert frequently cross the Atlantic Ocean and reach the Caribbean on the American side. Look at this photograph. You can see the America and Gulf of Mexico on the left side. And you see the red plume. These are the desert sand that is moving across the Atlantic Ocean towards the Caribbean area. The Saharan air layer, depicted in red color, is seen at west of America. Meanwhile, a plume of that air layer and its associated dust was moving through the Caribbean and approaching the Gulf of Mexico. This is a photo taken on June 29th, 2020. Dust and sandstorms are common in the desert regions of the world. Winds can whip the dust up to 2,000 million tons every year, high up into our atmosphere. It gets transported many miles away from the source. You see here a MODIS instrument on the NASA's Terra satellite. They captured this image. You see the image of thick plumes of dust stretching from northern Mexico. Mexico is at the bottom, you see here, Mexico at the bottom, into the Texas state in America, and New Mexico state here. You see that white dot of shade, white clouds light up there. They are the plumes of this dust moving from the Mexico into the United States. This is a photo taken on March 31st, 2017 by the NASA's Terra satellite. Similarly, winds sweep east also. What we have seen is moving towards the west, crossing the Atlantic. Now, winds sweep east, a mixture of Asian aerosols. Where from? Particularly dust from the Gobi Desert and pollution from China over Japan and towards the central Pacific Ocean. They move over Japan into the central Pacific Ocean on the east side. The exceptional heating in Siberia during January-June 2020 led to, Siberia is in the very northern part, nearer to the North Pole, that is north of Russia. Always snow all the time. But in such a place, there was a heating, a sectional heating in June 2020. Overall rise in temperature across the region during this time is more than 9 degrees Fahrenheit above the average temperatures recorded during 1951 to 1980. B, a shocking spike in temperature, sudden peak in temperature on June 20, 2020 at the Siberian town of Verkhoyansky, reporting 100.4 degrees Fahrenheit. It's like any other place in our country. All-time record in the north of Arctic region. This was recorded by the Russian Meteorological Service. So using satellite data, the Greenpeace Russia reported an estimated 47 million acres of forest, steppes and fields burned across Siberia since January 2020. 47 million acres of forests, steppes and fields. And in June, that means the fire continued up to June. And in June, a small Siberian town, which I mentioned, soared to 100.4 degrees Fahrenheit, breaking an all-time record for the Arctic Circle. Now let us look at the aerosols arising from the volcanoes. They are quite different from the desert aerosols. Droplets of sulfuric acid form in the stratosphere after a volcano eruption. And it spreads across the globe by winds and can remain for 2 years. Volcanic aerosols reflect sunlight and so cool the Earth's surface. The coolness experienced in 1993 was attributed to the Mount Pinatubo eruption in 1991, 2 years earlier, in Philippines. This was a very classical observation. Mount Pinatubo eruption, volcano eruption in Philippines in 1991. Look at this picture. This is the first eruption, first explosion. A large eruption occurred at Pinatubo on June 12, 1991, sending up a cloudy plume that reached an altitude of nearly 12 miles. See, 12 miles, the ash went up. On June 15, 3 days later, a second eruption took place. The volcano blew its top, causing high-speed avalanches of hot ash and gas, giant mud flows, and a cloud of volcanic ash that spanned hundreds of miles across. The eruption plume, the photograph taken from Clark Air Force Base, shot some 25 miles, that is 40 kilometers, into the air. You see, with what speed the ash comes up from within the volcano. It shot up to 40 kilometers high, creating a giant mushroom cloud in the middle to lower stratosphere. The sulfate aerosols spread rapidly around the Earth in about 3 weeks, reaching global average coverage by about 1 year after the eruption. You see that second eruption, the second eruption where the photo was taken from about, I think, around 12 miles away from the Clark Air Force Base. And you see the ash and other things shooting up 25 miles, roughly 40 kilometers, creating a giant mushroom cloud in the middle lower stratosphere. That is the ferocity with which a volcano eruption occurs. The ash throwing into 40 kilometers high from the peak of the volcano. Now, there is a third type of aerosols, human-made, that is anthropogenic aerosols. They arise from sulfate aerosols produced by burning of fossil fuels and smoke from forest fires. The major contributors of sulfate aerosols are Europe, Eastern North America, and Eastern Asia. They survive in the atmosphere for 3 to 5 days and reflect sun's radiation. Aerosols serve as cloud condensation nuclei and also ice nuclei. Natural aerosols such as sulfates, sea salt, or ammonium salts are the most common condensation nuclei in the pristine environments, that is in the clean environments where there is no dust, pollution. These are the natural aerosols. Varying of aerosols in the atmosphere can alter the climate. These aerosols enter clouds, increase the number of cloud droplets while decreasing the size of the droplet. These polluted clouds, that is when the aerosols enter into the clouds, they become polluted. These clouds last longer and reflect more solar radiation than non-polluted clouds. If you have got only natural aerosols, they are the non-polluted clouds. When the aerosols from the forest fires, salt, even dust, they enter into them, then they become polluted clouds, and they live long and reflect more solar radiation. Control on anthropogenic aerosol and vapor emissions to achieve higher air quality may weaken the benefit of reflecting more radiation. You see this point? If we do not want these polluted aerosols there, and if you kill it up, then the advantage is you have a better air quality. But if they are there, more solar radiation is reflected back and therefore warming is reduced. These two are contradictory. One gives the benefit, the other weakens that one. The greenhouse gases cause global warming, whereas aerosols tend to produce regional cooling. Computer models suggest that cooling effect of anthropogenic aerosols could offset the warming effect by increased greenhouse gases levels by 30%. These are the estimates by computer mathematical models that the cooling effect of the aerosols would offset the warming by about 30%. But more data can indicate the long-term outcome of these effects. Aerosol processes are highly complex, and the amount of cooling of aerosols in today's climate is also not very certain, because we have seen the type of sources. We have so aerosols from 4 different types in addition to anthropogenic. And therefore, their movement, their lifespan in the atmosphere, these are all different and varies from the place, varies from the latitude. And therefore, it is very difficult to say it with certainty. Understanding aerosol effects is one of the biggest challenges for climate scientists. Thank you very much for your patience. Indra?